Okay, let's get into it. We're about to take a journey to the very edge of the mathematical map. We're heading into a world of fractals that, well, they just don't play by the rules we're used to. This is a place where math starts to feel a little bit alien. You know the drill with fractals, right? Those beautiful, infinitely repeating patterns. They're predictable, they're elegant, but what if there was a whole new class of fractals that followed a completely different, a much stranger logic? That's the exact question that kicks this whole thing off.
And that question, well, it leads us to a brand new mathematical frontier.
On this frontier, you'll find what are called non-holomorphic fractals. You can kind of think of them as living in a universe with a different set of physical laws. For mathematicians, this is genuinely unexplored territory, and it is just full of bizarre behaviors and some really deep mysteries.
So, our guide for this little expedition is a recent paper from researcher Michael Bird. It's actually the 13th paper in a whole series that explores these weird fractals. So you can think of it as a logbook, from an explorer who's charting a strange new world.
So what's in this logbook? Well, it's not just a report, it's a quest. The paper sets out to solve 3 very specific puzzles that were left over from a previous adventure, paper 11 in the series.
All right, so here's the mission. It's got 3 parts. First, we have the mystery of the sign, which is all about figuring out a really important value. Second, the alien calculus puzzle, which, come on, that just sounds cool. And finally, there's the universal curve riddle, which is basically a hunt for a hidden pattern inside what looks like chaos.
So, the big question, does our mathematical explorer actually succeed? Spoiler alert? Oh yeah. This paper cracks the code on every single one of these mysteries, one by one.
First on the list, the mystery of the sign. There's this super important number, the Stokes constant. The thing is, nobody knew if it was positive or negative, and that one little detail would change, well, pretty much everything about the system's behavior. So, by using this powerful geometric tool, the paper proves, definitively, that the sign is negative. Mystery number 1, solved. Now, to solve the next puzzle, the paper had to pull out something with, and I am not making this up, the coolest name ever, alien calculus. Yes, that is a real, super advanced field of mathematics, and it's designed specifically to uncover hidden relationships that you just can't see otherwise. And this brings us right to the alien calculus puzzle. The problem was figuring out the behavior of this other group of fractals, but the rules were just totally hidden. So, by applying what's called Akale's alien calculus, the paper essentially puts on a pair of special glasses, and all those invisible rules just pop right into view. And just like that, puzzle number 2 is solved. And that brings us to the final challenge, the universal curve riddle. So researchers had a bunch of data points that just looked disconnected, seemingly random. And the question was, is this just noise, or is there some kind of universal law tying them all together? Well, the paper proves it's not random at all. In fact, all the points fall perfectly onto a single, universal curve. It's finding beautiful order in the middle of chaos. Now, finding a curve, that's one thing. But what really makes this discovery so amazing is that the curve isn't just some vague shape. No, it has an exact, predictable mathematical signature, a fingerprint. And the most crucial part of that fingerprint is a single clean number. The exponent that defines the curve is exactly 1/3. Now, in the wild world of theoretical math, finding a simple, elegant number like that, it's like finding a perfectly cut diamond just sitting on the beach. It tells you that you've stumbled onto something truly fundamental. So, 3 mysteries solved, a universal law uncovered. Is the journey over? Not a chance. You know how it is in science. Every answer just leads to even more interesting questions.
In fact, the paper says so itself. These solutions aren't the end of the road, they're the foundation. They're like the base camp for the next expedition. The paper literally says this work sets the stage for paper 14, which is where the next level of this whole mystery is going to be tackled.
And that's where we leave things. With these 3 riddles solved, we have a much clearer picture of this strange non-holomorphic world. But the map still has these huge blank spaces on it. So the real question is, what other beautiful alien structures are just waiting to be discovered in the next chapter of this incredible mathematical adventure?